Okay, ladies and gentlemen, we're going to look at that cricket problem. And if I recall in class, that was not your favorite problem. And as I recall when I put it on test 2, some of you weren't happy with me. Well, you better know how to do it now. So let's review it. The number of crickets, what we're going to do here, not the number of crickets. The number of chirps a cricket makes per minute is linearly dependent on the temperature measured in Fahrenheit. So in other words, there's a dependency. If you want to know how many chirps a cricket makes, it's dependent on the temperature. And linearly so, which means we can use the formula y equals mx plus b to help us determine it. Now here's our data. There are no chirps when it's 40 degrees Fahrenheit. There are 168 chirps per minute at 80 degrees Fahrenheit. So the first question is, let me make sure you can see this. Express the number of chirps C as a function of temperature T. And then the final question is, using our formula, how many chirps will there be at 90 degrees Fahrenheit? Now, if you want to, this problem's written out for you. I just pulled this off of the sheet that we did in class. It was your linear model sheet. We did it way back in Unit 1, and I believe we called it Supplement C. So if you wanted to get out Supplement C, all I'm really doing for you is reworking the cricket problem. Let me erase my board so I can actually work it. Now, I don't think it hurts for me to rework this because some of you never really got it. Okay. Here's the deal. All right, come with me to my board. Here's my deal. I have two ordered pairs here. I have the ordered pair 40-0, and I have the ordered pair 80-168. Now let me explain those two ordered pairs. 40-0. When it is 40 degrees, there are 0 chirps per minute. The number of chirps is output. The temperature is input. So basically, remember how the problem worded told us the number of chirps is linearly dependent on temperature. Well, what that means is we're going to put the temperature in, the number of chirps come out. So 40 degrees, 0 chirps, 80 degrees, 168 chirps. Also notice in this problem they keep referring to C of T. T would then be the input, C would be the output. You with me? C of T. Okay. So we have to find that function. Now in general, before I put in all the T's and all that kind of stuff, okay, what I want to do is I want to find the slope of this line. Well, slope is change in y divided by the change in x. Change in y means subtract the y values. 168 minus 0. Change in x means subtract the x values. 80 minus 40. $168 divided by 40 is equal to 4.2. So the slope of my line is 4.2. Now we're looking for the function C of t. And I know it's a linear function, so it can be written in the form mt plus b. All right, now we just found the slope. C of t is equal to 4.2 times t plus b. But unfortunately, I don't know what b is. Well, let me show you a pretty cool way to find that. Let's take the ordered pair 40, 0. Now remember, 40 is input, 0 is output. So if I come down to this equation, C of t would be 0. That's my output from that ordered pair. 40 would be my input. 0 equals 168 plus b. Therefore, b is a negative 168. Okay? So, I now have my formula. C of t is equal to 4.2t minus 168. And this is the function that shows the number of chirps is based on temperature, and it's a linear relationship. Now, I think the last question said, how many chirps would there be at 90 degrees? Well, it's a simple matter of plugging in 90, 4.2 times 90 minus 168. And I believe if we do that calculation, let me hit my calculator over here. 4.2 times 90 minus 168 will come out to 210. So basically what this whole problem is doing is making use of our y equals mx plus b formula. That's all.